We're going to solve a problem using the intermediate value theorem and Rolle's theorem. Here we have a problem that says use the intermediate value theorem and Rolle's theorem to show that f of x is equal to x to the 7th power plus 4x to the 5th power plus 3x plus 5 has exactly one real root between -1 and 0.
Alright, so we are going to use the intermediate value theorem to prove that there is actually a root between this interval, the restriction that we were given. So the intermediate value theorem, we need to make sure that this function is continuous on this restriction. So and we know that it is continuous because f of x, this function, is a polynomial. So it is going to be continuous on this function. Okay. Next, the intermediate value theorem says that if we let n be any number between f of -1 and f of 0, there's going to be where f of -1 does not equal f of 0, then there's a number c in the domain that we're given such that f of c is equal to n. Okay, so we're going to plug in the restrictions into the function to see if f of -1 is not equal to f of 0. So f of -1 is equal to okay, so that's -1, -4, 3. F of -1 is equal to -3. So now we're going to plug in f of 0. And we get f of 0 is equal to 5. So f of -1 does not equal f of 5. Alright, so that's good. And since we're using the intermediate value theorem to prove that there is a root, these do not equal each other. And f of -1 is negative and f of 5 is positive. Therefore, there is going to be negative, positive, at least one real root.
Now we're going to use Rolle's theorem to prove that there's exactly only one real root in between our intervals -1 and 0. In order for this to satisfy, it has to satisfy three hypotheses. Number 1, f has to be continuous on the closed interval of a and b. Number 2, f has to be differentiable on the open interval a and b. And number 3, f of a has to equal f of b. Therefore, there's a number c in the interval a and b such that our derivative has to be equal to 0. So we start with our function f of x, x to the 7th power plus 4x to the 5th plus 3x plus 5. Because this is a polynomial, it is continuous in the closed interval -1 and 0, and it is differentiable at the open interval -1 and 0. So we got the first two steps done. So on third step, we're going to have to prove. By proving this, we have to contradict our statement. So we're going to prove by saying that our function has more than one real root in between -1 and 0. So this means our derivative, we're going to give the letter C, has to be equal to 0. So we get our function again. And we take the derivative, which will be equal to 7x to the 6th power plus 20x to the 4th plus 3, and we equal it to 0. Well, because we see that our exponents are even, we determine that no number given to an even exponent can give you a negative number back. Therefore, by adding positive numbers cannot equal to 0. Therefore, our function f of x, x to the 7th plus 4x to the 5th plus 3x plus 5 has only one real root in between -1 and 0.
Just a quick recap. We use the intermediate value theorem to find that there is at least one real root. And we use Rolle's theorem to prove that there is exactly one real root in the function.